My name is Peter Ditlevsen. I'm a professor at the Niels Bohr Institute, and I work in the field of many things: chaos, complexity, turbulence, and climate dynamics. And what I am going to tell you about, and as I understand it without formula, is how the climate works, and that we'll see how that goes. And climate is a field of science in which there are probably as many disagreements as in cocktails, and there are disagreements on many different levels. There's sort of the disagreement in the sense of sort of the deniers, the flat earthers, saying that we do not believe this and that. That's from a scientific point of view not very interesting. That people have views like that. I mean, our understanding is based on solid knowledge of greenhouse effect and everything that we know. But we are asking questions that are further, questions that are sort of at the edge of what can really be known, where we don't even know if we can know these things. And the first thing that's of concern is, of course, that we have observed that the atmospheric content of carbon dioxide, which is a greenhouse gas, and I'll explain this in a short while, what this is increasing in the atmosphere. And that's been known for 100 years. It's been measured since 1957. 1957 was the UN geophysics year. And that year, a lot of measurements were launched. So we have temperature measurements from the ocean. We have this measurement of this carbon dioxide in the atmosphere, which was taken far away from any industry in Hawaii, in an astronomical observatory high in the atmosphere, far away. So this is really a signal of the global content of carbon dioxide. And you see very nice annual cycles, and that's really the biology sucking up CO2 and releasing CO2 in the winter. And then you say, how can that be? This is a global signal, but that shows that there's just more biology, more leaves, more land on the northern hemisphere. So this is really a signal of the northern hemisphere, summer and winter, you see in this curve. Now, it's been discussed for 100 years if this really is so much that this would influence the climate of the planet. And the big climate puzzle has really been to understand why is the climate changing? Why would there be ice ages? Because in the previous century, in the 1800s, 1830s and so on, people started realizing that things in the geology was such that it could not really be explained. Say why there would be big boulders in Denmark, and you can take these boulders and see they come from the mountains in Norway, and how would they be transported here? And sort of the saying would be, that's the big flood and from the time of Noah and things like that. That's of course never been sort of taken seriously by scientists. Not 100 years ago or not 200 years ago at all. But this was a puzzle, and it was solved by a glaciologist, a Swiss glaciologist, Agassiz, who studied the glaciers of the Alps and saw that they would really be pushing rocks and everything, moraines, and making landscapes that you now see. That's how Denmark is formed, and you see it in Scotland and many places. So they know that this place has been covered with ice. So this was the big climatic mystery for 100 years. How can that be? How do we explain that? So this is not a talk about ice ages, but I can tell you now that this puzzle is only partially solved. We do not, our models that I will talk about later, are not capable of doing it yet. So sort of the next biggest puzzle is to know, is our influence on the planet such that it can really change climate? This is the worry, and this was proposed already 100 years ago and calculated by a Swiss chemist Svante Arrhenius, who looked into the atmosphere and made some estimates on the absorption and so on, which I'll return to, and came up with the result that if you doubled the carbon dioxide, we would have an increase in temperature of a few degrees, which would be very nice. He was sweet. I mean, I think that would be, we should do that. But of course, it's been discussed later, you know, if this is the case, and will start being a worry. UN set down this panel that you all heard about, the IPCC panel, that was an intergovernmental panel on climate change, which should gather all the information to answer the question if climate was changing due to our anthropogenic emission of carbon dioxide. And there's been a report every 5 or 6 years, and the conclusions have been more and more sort of certainty that we do actually change climate. In this, you see in 1995, the balance of evidence suggests a discernible human influence on global climate. And you can imagine them sitting at these nice tables with politicians, breathing in their necks, saying take it easy. So they're very careful. In 2001, there's new and stronger evidence that most of the warming observed over the last 50 years is attributable to human activity. So that's sort of stepping up. And the last report here, which was sort of the warm-up for the COP15, is most of the observed increase in globally average temperature since the mid-1920s 20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. So, and probably they've known this all along, but politics sort of turned. The Al Gore effect's been that we can. This is a serious problem. Even people tied to industry takes this seriously. And this is. I'm just showing this curve to show the last part that I previously showed here is this increase here. So this is actually an unprecedented increase in carbon dioxide over a period of 500,000 years or 600,000 years. This is sort of the curve that Al Gore, I don't know if you saw Al Gore's film, but he'd have this curve all over the stage. You'd go over here, and then he'd have an escalator, and he would sort of be standing on the escalator and going up, and then he'd be pointing to this point here and say, this is very, very dramatic. Of course, it's a huge increase in carbon dioxide, but if you look at this is a proxy for temperature. You see these wiggles here, they are ice ages. And ice ages are huge changes in temperature. Of global change of temperature of perhaps 5 degrees. Okay, and this is what you sort of see here. But there's this little mystery here that we did not increase here 5 degrees yet. So there's more to it than carbon dioxide. But the kind of temperature change we're looking at here is probably of the same order as an ice age, going the other direction, of course, from that. So what is the physics behind that? How do we answer a question, how much will the surface temperature increase with the doubling of atmospheric CO2? Let's just look at the very basics of that. And this is the very basics. This is how much physics probably I will do. Now, this is the different components of the atmosphere, different molecules. And the reason that we do have a greenhouse effect is that molecules, they absorb the incoming and the outgoing radiation in the atmosphere. And that's where it all lies. And this absorption depends on the energy of the light coming in and out. Now, if you look here at the incoming light and the outgoing light, that we all understand very well from physics. If you look at the wavelength here, high energy is up here. This is short wavelength. This is the solar influx.